Start writing. Okay. Our topic today is circle. Circles. What all we will study and how we will study. Initially, we will study nothing of circle. I'll just take you a brief on congruency, because this is the way you will understand and retain. A brief on congruency. Then we will study a brief on circle. Then we'll study a brief on chord. I might not be following the textbook, but I ensure you that end of the day you'll understand everything. Chord. And then I would be going on some theorems. Oh, after chord, I would also speak about arc, then some theorems, and finally we'll speak about tangent. So we have lots to cover. If we are set, we start with congruency. These are prelims. Okay, congruency has nothing to do with this chapter, but I believe you should understand congruency. Otherwise, it will be difficult for you to pick up this chapter. Okay, congruency, congruency, congruency. Okay. This is just a teaser so that you understand everything. Okay. Now, the word congruency. Congruency means two objects are said to be congruent if one can be completely superimposed on the other. And as a result of this, all the corresponding measurements and specs are equal. In case of triangles, when we deal with two circles are said to be congruent if they are of the same radius. Right? Two rectangles are said to be congruent if they have the same length and the breadth. So one can, this is like the pack of biscuits. All the biscuits are congruent. Two triangles are said to be congruent if the corresponding, and if, rather I'll say not two triangles are said to be congruent. If two triangles are congruent, their corresponding angles will be same. Corresponding, remember, corresponding. Okay. We'll take a very easy way. And there are four ways in which we see congruency. So I'll just revise those four ways so that it becomes easy for us to understand. Okay. So let's take the first way. I'll take two triangles. Say this is my triangle ABC and this is triangle PQR. Now, what I'm trying to say is that these two triangles are congruent. Okay. So if they are congruent, the way we write is triangle ABC is congruent, equal, and a wave to triangle PQR. In congruency, children, the way you make the nomenclature is very important. ABC congruent to PQR means angle A will be equal to angle P. The middle B will be equal to Q. You just can't write ABC equal to RQP. You have to be very specific about the way. So when we solve congruency problems later on, say when you have a triangle class, which you don't have, they might not give you the triangle in this manner. They might orient it and give it in some other manner. Have you understood? So when we write in this manner. So the first congruency, we'll learn about the first congruency criteria. We are going to talk about the criteria. The first criteria is known as SAS. Two triangles are said to be congruent. Okay. SAS stands for side. Are you all aware of this or are you all not? I just wanted to know if you are not. That, okay, side angle side. Two triangles are said to be congruent if two corresponding sides are equal. Look at me because these things will come to you. This is getting recorded. If two corresponding sides are equal, look at the mark that I'm putting up, which means the measurement of this side might be different of this side. Two scalene triangles, two sides, and the angle included between them are same. This is called SAS. 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 Congruent. Have you understood? Okay. Criteria number two. Criteria number two is the ASA congruency. Angle side angle. Two triangles are said to be congruent if two corresponding angles are equal. Now look at the signs once again. The signs are different means it shows the measurement of this particular angle and this angle might be different. Okay. And the side included between them are equal. So this is known as angle side angle. Angle side angle. This is known as ASA. SAS then ASA. Understood? Okay.
Sir?
Yes.
Sir, could you repeat the ASA rule?
ASA rule stands for ASA, angle, side, angle. Angle, side, angle. Angle, side, angle stands for two triangles will be said to be congruent to each other. Let me again make this as ABC and this as PQR. ABC is congruent to PQR if two corresponding angles, any two corresponding angles, if we have picked up this, then this should be equal to this. Two corresponding angles and the side included between the angle. SAS ka just ulta, SAS, ASA. This is just there the side was included, here the side is included, here the angle was included. पक्का बच्चा समझ में आ गया ये दोनों? Okay. So we used to learn it like that. This is called SAS Bahu, SAS. This is Asa. And then the next is snakes. Next is called SSS. Two triangles are said to be congruent if each corresponding side is equal to the corresponding side of the other. Side, side, side. We call it side, side, side. Understood? PQR, ABC. But it can be a scalene triangle also. We have 5 actually. One more is there. One more criterion will be there. ये हो गया? No, angle is never say like that. Angle is symmetry. Symmetry. No. Is this an equilateral triangle? Can I make a bigger version of it zoomed out? Then also the angles are same. They are not congruent. Angle is always symmetry. Like when you give these games for kids to play, small triangle, big triangle, big triangle, big triangle, concentric circles. Children play with rings. Have you seen chota ring, bada ring? So they are not, they're similar. They are not congruent. Congruent means if I make you blindfolded, touching them, you cannot make out any difference. They will just superimpose one on the other. Have we understood this?
Yeah.
Okay, since I have drawn this, I am explaining this first. But otherwise, there are 2 more which will take in the next screen. Okay. This should be actually number 5. I'm not writing it as 4. Take it as 5. Number 5. 4 we will take on the next screen. Okay. Now this congruence criteria is specific for a right angle triangle only. Only for right angle triangle. Let's say this is ABC and this is PQR. Right. This is known as the RHS congruency. RHS. Right stands for right angle, hypotenuse, and side. Two right angle triangles are said to be congruent if they have a right angle, obviously 90-90, their hypotenuse are equal, and any one of the corresponding side is equal. Any one. It can be this equal to this, or it can be this equal to this. RHS. So what all you have to satisfy? Right angle, hypotenuse. Then you're left with two sides. Two में ये मत बोलो कि this is equal to this. No. Then the nomenclature will be different. So what nomenclature are we following? I am saying triangle ABC is congruent to triangle PQR. Then in that case, BC must be equal to QR. And obviously, if they are congruent, then AC will also be equal to this. But in this nomenclature, if you write BC, you can't write BC equal to PQ. BC, QR. Follow the nomenclature. SAS, ASA, SSS, RHS, one is left, and one will have another corollary also. Are we ready? Yeah. That's it. That's why this is a specific case for RHS. Right angle, hypotenuse, and any one side equal. That automatically makes us understand that the other one has to be equal. Otherwise, Pythagoras theorem is not applicable. Pythagoras theorem is what? Height square equal to base square plus altitude square. You said height is equal to height. Say altitude equal. Then base must be equal, na? वहीं से तो इसका जन्म हुआ. ठीक है? Next. Again, two triangles. Okay. This is our final one. Okay. So one will be the direct one and the other will be corollary. Corollary means what you can conclude from the other one. PQR, ABC, and PQR. Okay. Next one that we are trying to understand is called AAS. Angle side. AAS actually is a born out from ASA itself. You can take it. Angle side. So let's see that. It says that two triangles are said to be equal. Look here. Two triangles. What was ASA? ASA was a criteria in which we made it mandatory that the side should be between two angles. Do you agree or not? The side was between two angles. We'll give a little bit of relaxation out here. See, this says any two angle, and side. Well, the side may not be included. ऐसा कैसे होता है? It's very easy actually. Just see here. Let's say this angle is equal to this angle. Agreed? And this angle is equal to this angle. Agreed? Yeah. And we say that this side is equal to this side. Are we satisfying AAS, any two angles and any side? Tell me one thing. If the two angles are equal, is it not satisfied that this angle should be equal to this angle? In a triangle, if two corresponding angles are equal, the third should be equal. So are you not satisfying ASA out here? So from ASA comes AAS. But many children by mistake write ASS. तब लेकिन marks भी ASS जैसा ही मिलेगा. ASS नाम का कोई congruency नहीं है. Don't do that. If you write spell it like that, you get the marks also like that. AAS, ASA, SAS, RHS. That's it, done. So ASA is actually a pullout from, sorry, AAS is a pullout from ASA itself. ठीक है बच्चा? Have you understood? Can I now put a big tick on congruency? हम सीख गए. ये बहुत काम की चीज है. In physics and all, we'll need it a lot. RHS is clear or not? RHS is exactly Pythagoras theorem. Two right angle triangles are said to be congruent if they have a right angle, which they will have. The hypotenuse are equal and any one corresponding side. It can be base equal to base or altitude equal to altitude. Bas khatam. Clear, sir? Shall we go to the next one? Shall we now go to circle? Circle, circle, circle. I may not go in the order of the book, but ultimately you will come in the order of the book. Circle. So what is a circle? Okay. Now don't see the book, Kirtan. If you now see the book, you will get prejudice. Just close it. I don't need the book to be open. If you keep it open, it will cause me more trouble. Okay, what is a circle? We define a circle as a set of points. Set of points. Okay. And here I will write the criteria is that they should be equidistant from a given point. Does that make sense? Circle is a set of points which is equidistant from a given point, right? And that given point is known as the center of the circle. Let O be the center of this circle and equidistant from a given point, and this given point is known as my center of the circle. Now children, when you go to higher classes, what you will learn is that when a set of points obey any criteria, we call this as locus of points. It's a better word in geometry. So if somebody tells you define a circle, you will say circle is a locus of point. What does locus means? Locus means a set of points which obey a criteria. It means like a lot of marbles you're having on your hand, you have not just spread them on the floor. They have some criteria. And what's the criteria out here? Like what is a perpendicular bisector? A perpendicular bisector is a locus of point which are equidistant from two given fixed points. Like this. See? Have you understood what's a perpendicular bisector? Think that there's a line from this shoulder blade to this shoulder blade, and from my head to my toe is the perpendicular bisector of that line. So how is the perpendicular bisector? The set of points, this point, they are equidistant. Now you come close. Locus of points. So instead of writing set of points, we can use a better word called locus of point. A locus of point means locus stands for, locus means set of points which obey some condition. And in the case of circle, my condition is what? That they are equidistant. Which means if you pick up any 2 points, say P and Q, OP will be equal to OQ. Have we understood? Well, very good. So we come down to our next topic in circle. Our next topic is number 2. This was our number 1. We're trying to define circle. Next is chord. What is a chord? A chord is a line segment. Now, do you know what is a line segment? A line segment is a portion of a line. Means it has got endpoints on either side. They don't extend. A line extends infinitely on both sides. A ray extends only on one side, and a segment doesn't extend at all. Have you understood? So a chord is a line segment whose endpoints lie on any 2 points. Endpoints lie on any 2 points on the circumference of the circle. Endpoints lie on any 2 points. They can be any 2 given points. So that's known as a chord. Are we clear, bacha? So AB is a chord of this circle. Understood? Very good. A circle will have chords which range from small sizes to a maximum size and again come back to the smallest size, and the maximum size of the chord is always known as the diameter of the circle. Diameter is the longest chord. Maximum size. Okay. So if somebody says you which is the longest chord, my longest chord will always be the diameter. Are we clear till now? All fine? So what all did we learn? We learned what is a circle. A circle is a locus of point which is equidistant from a given fixed point known as the center, and all those locus of points together are known as the circumference of the circle. Like a segment which joins the center to any point on the circumference is known as the radius, and we have that. I hope you know about that. And now we're going to study about chord. A chord is a line segment whose endpoints lie on any 2 points on the circumference. The longest chord, known as the diameter, has its endpoints which lie diametrically opposite to each other. So we use a word called diametrically opposite. So whenever you hear about a word called, in the case of diameter, the endpoints lie diametrically opposite to each other. Yes, are you clear or not? Perfecto? Right?
Yeah.
Can I move the screen up now? Okay. Sure. Right. Let's go one step more. Our next topic that we'll understand, still with the chord, is we'll try to understand the concept of arc. Okay, let's try to understand the concept of arc. Now, what do we mean by arc? यहाँ से थोड़ा सा attention दीजिए because it will become little bit new. If you know it, then fine. If you don't know, then also it's superbly fine. But we should try to understand. AB, and this is my center O. Right, let's see. Now, we have our chord AB, right? If you follow the circle from A to B, that is a portion of this moon, that is known as my arc. Arc, A-R-C, arc. A to B, if I'm following along the circumference, right? Now, you can tell me that, sir, why did you follow A to B in this manner only? Why did you not follow A to B from this manner? You can also follow in this way also. This is also an arc. So in order to clarify that confusion, the first thing that we need to understand is in many foreign books, they will also show something known as the rotation of the circle. This is actually your way or your nomenclature or your way of understanding how you are naming your circle. So as I see my circle, my nomenclature is based on an anti-clockwise rotation. Is that clear? If it is anti-clockwise rotation, then I come across two arcs. One of the arc is known as AB. The arc is written in this manner. And then there will be another arc which is also known as BA. Sir, why don't you write AB this way? No, I will not write AB this way because AB is this. Can I not write this way? No. Since the circle is rotating in this way, AB means this arc itself. We cannot name it in this manner. We can rather go in one direction, AB, BA. AB is the smaller part, so this will be known as my minor arc, whereas BA will be known as my major arc. Is this clear or not? I'll tell you once again. Whenever you look at a circle, now let's see the converse of this also. Let's take a circle, which is now, this is my circle. And in this circle, I'm saying that my circle is now rotating this side. Agreed? Okay. And in this circle, what we do, we take our arc. Let's say our arc is similar in this fashion, right? And I name this arc as again AB. AB, and the center is O. Now, if I write AB as an arc, I'm allowed to write, and I can also write BA as an arc, but my AB will be now the major arc. Do you understand or not? BA will be my minor arc. Is this thing understood? Why it became minor arc and why it became major arc? Okay, very good. Do you understand that an arc is a portion of the circumference? Have we understood this? Okay. We see that AB is a smaller part and BA is a bigger part, right? Whenever you name an arc, now see, if I name this arc as AB, Dhruv has every right to name it as BA also. So we have to follow a nomenclature. That nomenclature is given by first freezing the orientation of the circle. Whether you are working, I am working, or anyone, once this arrow is given, it is frozen. The circle has to be read from anti-clockwise rotation only. I'm saying the larger circle. In that case, do you have the freedom to name an arc in this way? No. We will only name it in this way. Sir, I want to start from B. I love opposing you. Okay, start from B. Then from B, we go to A. Have you got a bigger chunk of the circumference? Yes. So your BA is the major arc. And then after you reach A, you are left with what? AB. AB is your minor arc. Can you go BA this side? No. The circle is rotating this way. But is this manner frozen that, sir, we should always see it anti-clockwise? Nothing like that. For that, I have taken the reverse example. You can take the circle rotating clockwise also, your wish. But once you have taken clockwise, make sure you don't start naming anything anti-clockwise. So now where do we start from? You say B or A? You say A. From A, we are allowed to go this side. So the first point you come, where is B? Are you getting a bigger chunk? Yes. So my AB is major arc. And after coming B, you're only left to go this side. So BA forms my minor arc. बच्चा ये समझ में आया कि नहीं arc का concept? Got it? Okay. If you have understood arc, then the next thing that we would like to understand is, angle subtended by an arc. Okay, we'll take this a little bit later. Okay, we'll take this a little bit later. We have understood two more things we'll understand. Is this okay so far? Okay, let's go a little bit. Let's move forward. Okay. Our next concept will be, so what all did we understand? We understood chord, we understood arc. Our next part will be to understand something which is known as okay. Our next topic would be angle subtended. Now this is the most critical one which children have slight issues. You should not have. I don't know whether it's number 3, maybe number 4. Angle subtended by a chord at the center of a circle. Let us first understand it from the chord's perspective, then we'll understand everything. Don't worry. Okay, so let me make a chord. This is a chord. And let the chord be AB. So we have to understand a little bit desi out here, okay? Angle subtended by a chord at the center. AB. My two shoulder blades represent AB. A, B. Understood? Angle subtended by a chord means I take out my this hand and I take out my this hand. And then I'll ask for forgiveness. हजूर माफ कर दीजिए हमको. और कहाँ माफी मांगेंगे? सेंटर पे माफी मांगेंगे. बिल्कुल. So we will ask for forgiveness where? We'll ask for the forgiveness at the center. Do you understand now? Then what is O and OB? Radius. These two are the endpoints of my chord, and these two hands will become the radius. And I'll ask for forgiveness. Where do I ask for forgiveness? At the center. The angle that you will be forming at the center, this is that angle theta, is the angle subtended by an arc, by a chord at the center of a circle. Have you understood? Subtended means what is the angle that the chord is making at the center? By asking for forgiveness. As simple as that. Otherwise, you don't understand the meaning of the word subtended. Subtended का मतलब होता है माफी मांगना. माफी मांग के आप नहीं, इंग्लिश में माफी मांगना नहीं होता है. Subtended means how much is it measuring. So you the best to understand is आप कितना measure कर रहे हो. Have you understood? Angle subtended. Now my question to you is, what is the angle subtended by the diameter at the center? 180 degree. 180 degree. Have we understood this part? Diameter. Diameter. Now this is one end of the chord, this is one end of the chord. They're diametrically opposite. My throat is the center. So my hands have to ask for forgiveness always at the center. Understood? But the challenge lies now. The challenge that we'll understand now is, okay, this much we have understood. Then a little bit more diversion. We'll come back to the challenge. Now 3A. 3A, we will get to know something about what is known as a segment. What is a segment? Okay, let's see what is a segment. Whenever you have a chord, say AB, pay attention here, huh? Look at the board. Whenever you are having a chord, imagine your circle to be a fully roasted lijjat papad. Fully roasted lijjat papad. And the chord is something where you'll be breaking it. And don't imagine it to be this diameter. Imagine that this is some chord, which is not the diameter. Obviously, if you are like Dhruv and he has a younger brother, he'll give the smaller piece to his younger brother, bigger to himself. Then what you form out here is known as a segment. So whenever a chord is drawn, a chord divides the circle into two segments. This will be known as my major segment. Children, do you understand this? And this will be known as my minor segment. So our next topic to understand was segment. What is a segment? However, if you take the diameter is when the mother is making the slice on the pizza and both the children get half of the margarita pizza. Half. In that case, you don't have a minor segment and a major segment. You have equal segments. Otherwise, if your chord is not the diameter, then definitely you'll give rise to one minor segment, one major segment. Very easy. This chapter is lots to learn, easy to learn and easy to forget. That's the only thing. It's easy to learn. Nothing is coming from the heavens. Have we understood? Okay. Now our next one, 3B, is to understand about something called sector. Sector. Okay, pay attention for sector. Before explaining you sector, what I'm doing is that I'm trying to take away this chord. Yes, gone. Chord is gone. Sectors are always something, whenever you see a segment, for segment formation, chord is necessary. For sector formation, arc is necessary. So let's put a rotation to this circle. The circle is rotating in this manner. Got it? So I have got an arc which is AB. Do you agree? And I have got an arc which is BA. Kirtan, my AB would be minor arc. Srinika, any issue on this understanding? Just see. Look at the rotation. So AB is the minor arc, BA is major arc. Sector is the area enclosed between two radius and an arc. Oh my dear, it's the slice of the pizza that's come out. Segment was very desi, it was popper. Sector is pizza. This slice. How do you get to eat a pizza? You're eating a sector. Got it? So this sector will be known as my minor sector, and this sector will be known as my major sector. So what do we understand? A minor arc will always chop out a minor sector, whereas a major arc will always take out a major sector. Is it clear? Again, I'm saying very lot of things to learn, easy to learn and easy to forget. A minor arc will chop out a minor sector. Okay. The total angle that you make at the center is how much, children? 360 degree. So my dear kiddos, if this angle becomes theta, then this angle becomes 360 minus theta. Have you understood? So how do we write it now? How do we write these angles? So we call this, as you wrote, angle subtended by chord at the center of a circle. You are now ready to understand something more, which is known as, on the same diagram, I'll continue that. Number 4, angle subtended by an arc at the center of a circle. This will be initially a little bit of a problem. I'm upfront telling you. Arc at the center of a circle. Angle subtended by an arc at the center of a circle. Right? Have you understood? Now, when we talk about an arc, obviously there will be two arcs. One will be a minor arc and one will be a major arc. If I look at my example, AB is my minor arc and BA is my major arc. Have you understood? Have you understood? Okay. Now, how to understand the angle subtended by an arc. Now, again, look at me. For the minor arc, it is very easy to understand. In the case of minor arc, look at me. The arc has formed from, say, this shoulder blade of mine to this shoulder blade of mine. Chord is missing. It's a curve now. Again, maaf kar dijiye. Theta. Minor arc is subtending theta. Major arc का केस दूसरा होता है. Minor arc is this, major arc is the remaining portion. It's a reverse subtending. If minor arc subtends like this, major arc subtends like this. Have you understood? Putting my hands like the Mitsubishi logo. This is my leg, Mitsubishi logo. This to this is a minor arc. Imagine this is a big circle I'm trying to weave with my hands. Look at me. Why are you looking at the door? Otherwise, I am doing this exercise for you. So these are my two arms, my two radius. The angle formed here, obviously this is the minor arc, the one on the top. So this is the angle subtended by the minor arc. My throat is the center. And this much portion of pizza you have eaten away. What am I left with? I'm left with the bottom portion. The angle subtended by these two hands now with the whole bottom portion is the angle subtended by the major arc. The minor arc will always be acute जैसा रहता है. Minor arc is acute. समझ लो, इस केस में acute है. Major is reflex. But in the case of diameter, you don't have major, minor. You have two arcs which are same. So both will subtend 180 degree at the center. Are we clear? Diameter, they will subtend 180 degree. So have you understood what is angle subtended by an arc at the center, angle subtended by a chord at the center? Both are same. Angle subtended by a chord and angle subtended by an arc are same. Clear this part?
Yes.
Shall we go ahead more? Okay. Now something more with chords. Again, we'll come back to arc. Arc is going to haunt you in this chapter. So let's give you some relief from arc for some time, and let's go back to chords. Now this is a theorem, okay? This is a theorem, and you can use it as a standard result. Theorem. Equal chords are equidistant from the center. Okay, before going ahead with this theorem, try to understand one thing. Okay, 1 minute. Try to understand this. Let this be my chord. My center would be some point which is out here. Say my center is somewhere here. Try to understand. You're talking about a distance of a chord from a center. In other words, we are trying to talk about distance of a line from a point. By convention, we always say that now there can be an option for us to have many distances. Don't you think this is a distance? Yes. Don't you think this is a distance? This is a distance, many things. So the nomenclature says the shortest distance is always the perpendicular distance. And when we say distance of a line from a point, it always refers to the shortest distance. And by default, it will always be the perpendicular. From any point, draw a perpendicular to that particular line. Whatever is the distance we say, that is the distance of the point. Otherwise, हम distance measure नहीं कर सकते. What is the criteria? Before going to the theorem, we should first understand what is distance of a line from a point. Distance of a line from a point is the shortest distance, and the shortest distance is always governed by the perpendicular drawn from the point to the. इससे छोटा और कोई हो ही नहीं सकता है. If you don't make it perpendicular and you start making it some other angle, it will never be the shortest distance. Then you will weave a triangle. Anything which is not perpendicular to it means you will weave a triangle. The straight line is the shortest one. Have you understood? So what does our theorem say? Our theorem says equal chords. So we should have two chords in this theorem, right? अपने से एक ही नहीं संभल रहा है, and I'm introducing two chords. So let's have two chords. But the criteria is that the two chords should be equal. So let's make two equal chords. Let's say these two chords are equal. Have you understood, children? So we have AB and we have PQ, and this is my center. We say equal chords are equidistant from the center. Now, what is the distance of AB? What is the distance? And let's say this is O. Sorry. Let's say the center is O, right? So the distance is this perpendicular, and here the distance is this perpendicular. And let me give it a name. Let's say this is M and this is N. So the theorem says to me that if AB as a chord is equal to PQ, then OM should be equal to ON. Have we understood?
Yeah.
Acha. The first thing also comes is, sir, how do you understand? We'll see two different laws. What you call one more theorem also out here. Before this, let's understand this. Now they are equidistant. So let's just try and see whether equal chords are equidistant from the center or not. So you can join this line. Okay, let us join this with a different color. Let's say we join this, and then you join this. You can prove that the two triangles are congruent. Easily we can prove them. Before that, actually, I should have said one more theorem, then it would have been easy. So hold this proof. Let me write another theorem out here, and then we'll do both together. Don't worry. You have understood this one, right?
Yeah.
Okay. The other theorem is the one that is actually before this. Okay. The one that is before this is if I can take this as say B, I should have had an A. The A is the perpendicular from the center to a chord, okay, bisects the chord. The perpendicular from the center of a chord, from the center to a chord, bisects the chord. So let us try to understand that. Say suppose these are not there and this is also not there. We'll come back to it. So imagine for the time being we don't have a PQ. We don't have a PQ. So we are trying to say that the perpendicular from the center to a chord, this perpendicular, it bisects the chord. That means if OM is perpendicular to AB, then AM is equal to MB. Very easy to prove. So how do you prove it? You can just join these two and just look at these two triangles. I'll just do it verbally with you. Just look at these two triangles, right? These two triangles are congruent. How to say these are congruent? Right angle, right angle. Then the hypotenuse are equal, both are radius, and any one side. So we'll take OM as the common side. So both the triangles are congruent. If both the triangles are congruent, then don't you think that AM should be equal to MB? Corresponding parts of congruent triangle, which we call as CPCT. Corresponding parts of congruent triangle. We always use this word called we use this word called CPCT. It stands for corresponding parts of congruent triangle. All of you, are you clear with this? If you have any doubt, let me know. I'll stop. We just tried to prove that the perpendicular from the center to a chord bisects the chord. It means that if you are drawing a perpendicular, so in other sense, when we go to the next theorem, what we understand, the shortest straight line distance, which is also governed by this perpendicular, it bisects the chord. Now we go to the next one. It says if two chords are equal, then they are equidistant from the center. They are equidistant from the center. So how do we prove that? Again, very simple. Just join these two now. Okay. Yes. So what are criteria do we have? This is also 90 degree. Now if you look at these two triangles, equal chords are equidistant. Right angle, hypotenuse are both radius, same. Half of this should be half of this. That means this side is equal to this side. So RHS wise, both these are congruent. Have you understood? Therefore, corresponding parts of congruent triangle OM must be equal to ON. Anyone has any doubt? I can explain again. If you look at these two triangles, both are right angle triangles. Our criteria solved. Hypotenuse equal to hypotenuse solved. We need any one more side. So we take MB equal to NP. Who told you? Sir, both the chords are equal. Half the chords must be. Sir, who told you it is half? If this is perpendicular, then it bisects the chord. We just learned it. Clear? This was the third section of this chapter, all about chords. We are done. Now comes the most important part, which is angles. Ready? You know what is angle subtended by a chord? Angle subtended by an arc. Okay, चलते हैं थोड़ा और आगे. Okay. So time to draw one more circle. What did our good friend write? You all were laughing. Oh, all those crocodile tears. You say that, why are you apologizing on a live telecast next time when you meet him tomorrow in the bus? We saw some live telecast. Okay. Now let us understand some more things. Okay. So let's make one chord now. Again, not a theorem, just a concept. So this is known as AB. AB is a chord. And whenever you have a chord will always break two segments in a circle. Major segment, minor segment. Understood? Now, this chord also has the authority to make an angle or subtend an angle at any point on the circumference also. Why do you think you should only ask forgiveness at the center? You can ask forgiveness on any point on the circumference also. In that case, we will say angle subtended on the circumference, at any point on the circumference. Have you understood? So that will look like something like this. Say this particular angle, ABM. So we say, what is angle AMB? Angle AMB is the angle subtended by a chord at any point on the circumference. Have you understood? No, no, I'm saying when they say subtended at the center means what? And subtended at any point on the circumference. Subtended means the two arms should go and meet. Now they are no more radius. When you subtend at the center, then the two arms are radius. Have you understood? However, don't you, dear children, also think that it can also subtend an angle on this part also? Why should the minor segment be left behind? It has not done any fault. You can subtend an angle at any point on the major segment. You can subtend at an angle at any point on the minor segment. Now understand. Please understand. If you are trying to view this particular angle, then what will you call? Angle subtended by the chord on the major segment. And if you want to see this one, then you will say that this is angle subtended by the chord on we have a better word. This will be the word they will use, alternate segment. So you should very well understand the meaning of alternate segment. Alternate does not mean minor. If you are concentrating on this side, then this angle is this segment is the alternate segment. So whenever you hear about this word alternate, you should always club it with the word segment. Alternate means alternate segment. If this is my segment of interest, the alternate segment is this. If this is my segment of interest, then the alternate segment is this. Have you understood what we mean by alternate segment? Very good. This is nothing but a cyclic quadrilateral also, which we'll understand later. That's also part of this chapter. I forgot to write. Cyclic quadrilateral is a quadrilateral whose four vertices lie on circumference. चलो सीख ही लेते हैं यहाँ पे. Cyclic quadrilateral. Cyclic quadrilateral. A cyclic quadrilateral is one. So in this case, we will say A. Acha, do you know how to name a cyclic quadrilateral? You have the freedom to either go clockwise or anti-clockwise, but no jumbling. So either it is ANBM or it is AMBN. Your wish. Okay, so we say that AMBN is a cyclic quadrilateral. What is the criteria? That all its four vertices should lie on a circle. And in a cyclic quadrilateral, we have a special case that the opposite angles, now again you will laugh, sigma opposite angles is equal to 180 degree. The opposite angles are supplementary. This now wait, in a generic quadrilateral, sum of all the angles is 360 degree. There is no written rule that the opposite angle should be 180. But if you are a cyclic quadrilateral, you will be 360 for all the four, but the opposite angles will be 180 degree. ये भी हमें जरूरत पड़ेगा. Opposite angles, sum is always 180 degree, and sum of the four angles, that is obviously 360 degree, and it obeys. अगर ये दोनों 180 होगा, ये दोनों भी 180 है, 180 जोड़ेंगे तो 360 हो गया हमारा. Clear? Now the last part, which is the most interesting part. हाँ, ये थोड़ा लंबा है, हो जाएगा. चलें? अच्छा, I will give you ample time to write. I just don't want you to write anything right now as I explain you the last theorem, okay? Because if you start writing now, you will not understand anything. Just follow the board initially. Don't write anything. लिखोगे भूल जाओगे. I'll give you time. यहाँ से 3-4 theorem निकलेगा. I don't know how many count, but we'll go on seeing it. Okay. My language may be different from your book, but they all mean the same. The angle subtended by an arc at the center of a circle is equal to twice, I've just made my writing smaller, twice the angle subtended by it on any point on the remaining part of the circumference. Okay, we'll try to absorb this first. And just absorb. Angle subtended by an arc at the center of a circle is twice the angle subtended by, and from here 3-4 cases will be born. Twice the angle subtended by the arc on any point on the remaining part of the circle, remaining part of the circumference. So let's see what it is. Okay, your book definition might be a little bit smaller, but this way you'll learn it. So let's now first freeze an arc. So what, children, I'll do, I will not make any chord out here. I'll just freeze an arc. I'll just freeze an arc first. And arcs can be of many types: major arc, minor arc, equal arc. That means this theorem which you are going to study now will be, we should study it for a minor combination, we should study it for a major combination, we should study it also for an equal combination. Hai na? Arcs can be of 3 types: major arc, minor arc, equal arcs. So let's start with the very simple one, minor arc. And let me now name my circle. So let's say the circle is rotating in this way. This is my center O, and this is A, and this is B. So our first criteria that we are trying to see, children, is for the minor arc. What is your minor arc? AB. And let's see what is the angle this arc is subtending at the center. So what is the angle the arc is subtending at the center? Okay. P is any arbitrary case. First, let us concentrate on AB. AB is my arc. And after that, I should concentrate on what? I should concentrate on this line on any point on the remaining part of the circumference. So if you take out AB, the remaining circumference is BA. And P is that point, any point. P could have been here, P could have been here, P could have been here, P could have been anywhere. I have drawn it here because it makes you understand better. Have you got it? Our theorem says that if this angle is theta, then this angle should be 2 theta. Angle subtended by an arc at the center is twice the angle subtended by the arc on any portion. Got it? This is called the Namaste theorem. Namaste. Why Namaste? Because in order to prove this, we will make a Namaste formation. Let's see the Namaste formation. This is the Namaste formation. Right? We'll try to prove this. So let's see some easy way of proving. So concentrate on the triangles. Let's concentrate on the triangles AOP and triangle BOP. Okay, don't you think both are isosceles triangles? Yes. This is radius, this is radius, this is radius, this is radius. I told you in last class that isosceles triangles, the base angles are same. So don't you think that this angle should be equal to this angle, should be equal to this angle, should be equal to this angle? First of all, let us see whether they are congruent or not. Both the triangles are congruent also. They'll automatically come out congruent. This angle is same, this angle is same. Okay. Now, if I take this particular angle, okay, these two angles are equal means this angle is also equal to this angle, obviously. But let us not break our head on that. Okay, let me take this angle, say, as X. X is the exterior angle which should be equal to 1 plus 2. Exterior angle is sum of two opposite interior angle. Do you know this theorem or not? Exterior angle is equal to sum of two opposite interior angle. Any exterior angle is equal to sum of two opposite interior angles. This is a theorem. Exterior angle is equal to sum of two opposite interior angles. Okay. So x is equal to 1 plus 2. Similarly, if I have a y out here, nobody will ask you to prove. If you have a y out here, then y should also be equal to same 1 plus 2. Right? And 1 is equal to 2. And let's say these two angles are, say, let's say they are different. This is 4, and let's say this is, if this is 4, then this is also 4. So if this is 1, should I not write this also as 1? I should write this also as 1. Makes it better now? Because these two angles are equal. So let us make the symbols also different. Right? It makes generic case. This angle will be equal to this angle, and this angle will be equal to this angle. Clear? Okay. Because who knows, this one may be smaller, this one might be bigger also. If my point was here, then this arm will be smaller, this arm will be bigger. So we are taking a generic case in which, understand children, 1 and 1 are equal. It does not mean that 1 is equal to 4, but 4 and 4 are equal. Understood? Can I write x is equal to 1 plus 1? Exterior angle equal to sum of two opposite interior angle. Can I write y is equal to 4 plus 4? And instead of making this as 1 and 1, 1 and 2, I can write as 1 and 1. So if I add both sides, I get x plus y. And what do I get here? 2 times of 1 plus 2 times of 4. This is x plus y. So if you take 2 as common, it's 1 plus 4. Now what is x plus y? X plus y is nothing but my 2 theta. So if this is theta, then x plus y, I should rather write it like this. So write it like this. So if this is theta, then this is x plus y. X plus y is equal to 2 theta. Did you get the criteria or not? Did you understand? Once again, let us see the proof. I have mentioned this angle as x, this angle as y. Theorem says ये theta है तो ये 2 theta होना चाहिए. Theta क्या है बेटा? Theta is equal to 1 plus 4. Do you agree? And what is 2? And a theorem says this is 2 theta, but I am taking this as x plus y. The theorem says x plus y should be equal to 2 theta. Should be equal to 2 theta. That's what we are trying to prove. X is equal to 1 plus 1. That is 2 times of 1. Y is equal to 4 plus 4. 2 times of 4. Now please don't be super idiots to multiply this 2 into 4, 8. This is 4 means angle 4. So you take 2 common, angle 1 plus angle 4. Angle 1 plus angle 4 is what? Theta. Are we clear? Ashmita, are we clear? If not, tell me, I'll explain again. I'll not proceed further.
Sir, I didn't understand how 1 and 4 are equal. If I want 1 and 4 to be not equal to
Why 1 and 4 will be equal? P can be any point here. चलो P को यहाँ पे ले आओ.
P can be any point.
हाँ, P को यहाँ पे ले आने से कैसे इक्वल होगा? इक्वल नहीं होगा ना बेटा.
No, sir.
ये तो आपके अंडरस्टैंडिंग के लिए ऐसे बनाया. इसलिए कैसे दिख रहा है? ये नमस्कार जैसे दिख रहा है. This is called the Namaste theorem.
Okay, sir.
Have you understood?
Yeah.
Angle subtended by an arc at the center of a circle is twice the angle subtended by the arc on any point on the remaining circle. Which means, now I will mutate this diagram. Which means, and you can copy from the video also, because I won't allow you no time. We will be losing time. We have to cover. Okay. Which means that if my P would have been somewhere else, where, sir, if P would have been here, P could have been here also. Where? Here. Even in this case also, if this is 2 theta, this has to be theta. It's not right angle. Who says it's right angle? Angle subtended by an arc at the center is twice the angle subtended.
Okay.
Angle subtended by an arc at the center is twice the angle subtended. It can be here, it can be here also.
Oh.
Which now makes us understand. Well, we'll go to the little bit next one. Okay, ये पे समझ लो.
But sir, can you explain that again? I didn't understand.
P point can be anywhere, no beta. P can be here also. P can be here also. So it's not that a P should be here. It can be anywhere. But just the criteria is that the angle subtended at the center is twice the angle subtended at any point. Is it getting into your...
Yes.
Hanji?
So that endpoint will still be the same.
So let's make a fresh diagram and show you. Okay. Let me take an R at the center. So this is frozen. Okay. This is angle subtended by the arc, angle subtended by the arc at the center. Are we fine? Now look at me. Now I'm drawing some solid lines. First criteria, my P point is here. Nobody can stop me. It can be here. Second criteria, my P point is somewhere here. Third criteria, my P point can be somewhere where my P point can be somewhere here also. As long as this point lies on any point, in all these cases, children, if this angle is, this is theta, this is theta, this is theta, all are P. P1, P2, P3, n number of P's you can have.
Yeah.
Which gives us our next theorem. Our next theorem is based on this itself. Angles on the same segment of a circle are equal. Wow. Now again you bring the chord wala funda out here. Now let us draw the chord. Okay, let's draw the chord. If AB is a chord, don't you think all the three angles are on the major segment? So angles on the same segment are always equal. Iska janam kahan se hua? From that angle subtended at the center. Beautiful theorem. This is known as the trouser theorem. Pant ki tarah dikhta hai. Dekho dono pav hain. This is called the trouser theorem. So we learned namaste. Namaste is followed by trouser. Angles on the same segment are always equal. So when you solve problems, children, you won't get the problem like this. You will get a problem like this. अभी ट्राउजर जैसा दिख रहा है ना, पैंट जैसा, वो बोलेगा this is 30 degree और इसको x बोलेगा. X should also be 30 degree because they are angles on the same segment. Have you understood? You will get it like this. Not like that. It's already understood. It's on the same segment. Even if you draw a chord, you don't draw a chord, it's lying on the same segment. And same would have been the criteria if it was like this. Even these two angles would be same. They are also on the same segment. Corresponding means?
Like, everything has to be over there.
No. These angles on the same segment. This angle, not the bottom. Bottom का सवाल ही नहीं आता है ना. Angles on the same segment mean these two angles. Segment means segment forming the angles. Mountain. Now we go to our next case. If the what was our next case? If the arc is equal arc.
Okay.
The theorem has to be studied. That will give you another theorem. Okay. एक और. अभी हम सीखेंगे samosa theorem. What theorem? Samosa. First we understood namaskar. After namaskar came trouser. Now after trouser we will get samosa, but onion samosa. What is the shape of onion samosa? Triangular. Triangular. So इस केस में हम क्या देखेंगे बेटा? The same theorem, but we will say arcs are equal. Arcs are equal whenever I write, your mind should immediately think that if there is a chord, the chord has to be the diameter. Do you agree or not? Arcs are equal means the chord has to be the diameter. Diameter can be in this way or that way, whatever. Okay, this is one. Then second is segments should be equal. Segments are equal. Understood?
Yeah.
So let's take 2 points which are exactly diametrically opposite now. So let's say this is 1 point and this is 1 point. This is my center, which is O. Right?
Yeah.
What is the theorem? Angle subtended by an arc So there is no point in now giving a rotation, but still you will say, no, sir, we want a rotation. You said so. Angle subtended by an arc at the center. So my arc is now a semi-arc. So if it's a semi-arc, the angle that it will subtend at the center will be how much? 180 degree. Is twice the angle. Now which arc are you considering? AB. On any point on the remaining part, means remaining part is BA. And if you are considering BA as the arc, then any point is AB. So let's consider AB as our arc. Let's consider our arc as AB. It's easy for us to understand. You can also take BA, but I am proceeding with AB. Doesn't make any difference. So if I'm proceeding with AB, then I see, and let us take any other point. Any other point. So my any other point is now a point P. Do you agree?
Yeah.
This has to be 90 degree because this angle is 180 degree. This is a very generic case, which gives my next theorem, which says my next theorem is angle in a semicircle is a right angle. This is the exclusive finding of that case. Angle in a semicircle, Samosa theorem, triangle. Angle in a semicircle is always a right angle. Sir, where did it get born from? Same formula. That the angle subtended by an arc at the center is twice the angle subtended by it at any point on the remaining part of the circle. Sir, if you would have taken BA as the arc, yes, I take BA as the arc, then in that case, where do you think that we should have had our, then remaining part would have been this. And in this case, this angle would have been 90 degree. And this exactly proves opposite angles of a cyclic quadrilateral should be 180 degree. But this is very specific. Huh? This is 90. Did not be 90 always. This is a specific case. ऐसा केस में क्या हो जाएगा? Rectangle हो जाएगा. हाँ, two opposites 90 means the other two should add up to 90. Have you got it? So geometry is very interesting. The third one still remains. The last one will see that if you are taking a major arc, that is where children get a little bit confusified. Let's take the major arc one. Have you understood this? So what all did we understand? The first rule that we understood is angle subtended by an arc at the center of a circle is twice the angle subtended by the arc at any point on the remaining portion of the circle. This is the master theorem. This gave birth to the first one in which we saw the Namaskar was to prove. That was the Namaskar theorem. This is the Namaskar. Then we came to the trouser, the pant one. Pant one tells me what? Angles on the same segment of a circle are equal. Then we went to a criteria where we said that first one was a minor arc, now an equal arc. An equal arc gives me angle samosa. Angle in a semicircle is a right angle. And the third one doesn't have any name, and we are going for if the arc is a major arc. Chale? So let's see a major arc, and then we will conclude. You can do problems also. Thank you for your cooperation that you have been hung. नहीं तो क्या हो जाएगा ना, एक शॉट में नहीं होने से मजा नहीं आता है. चलिए. So here I have nothing of a theorem to explain you. I'm just explaining the same theorem from the perspective of a major arc. So we see it from the perspective of children what? Major arc. So let's see a major arc now. Can anybody tell me what is the major arc in this circle? BA is the major arc. Very good. BA. BA is the major arc. Okay. Now let's see. This is my center O. And you cannot get it wrong. I'll show you why you can't get it wrong. I'll show you why you can't get it wrong. Arc will always form. Now the first question I can have a doubt is, sir, angle subtended by major arc BA at the center. Sir, ये वाला होगा कि ये वाला? मैं तो आपको बोला ही था, minor arc हमेशा ये होता है. This is minor arc. Minor arc ऐसे माफी मांगता है. Major arc कैसे? Minor arc is like this. Major arc is like this. So what is the angle subtended by the major arc? This angle. This is the angle subtended by the major arc. No, whatever it is, we are not writing 360, but you should understand which is the angle. You should show the angle with an arrow. Have you understood? So the angle is, this is our major arc angle, which is BOA. This is the angle subtended by the major arc. This angle should be twice the angle subtended by the major arc on any part on the remaining part of the circle. Now, remaining part is only minor because the major is our consideration. Remaining part is anything minor. So P point should lie between AB. So AB पे P point ले आते हैं, आ जाओ. So let's say this is the P point. This is any point. Have you understood till this much? Which means if this angle is theta, this is 2 theta. Angle subtended by an arc at the center is twice the angle subtended by the arc at any point on the proof तो करके दिखाया ना number 1 में. हाँ, that's a generic proof. That proof you can draw again a straight line and proof here also. Exterior angle, interior angle, same. The only thing is that you should understand that this is an angle. Now our first theorem was what? Angle subtended by an arc. Let's look at the first one. First one was this one. Angle subtended by an arc at the center is twice the angle. It gives me rise to any two angles at the same segment. There can be 3, 4, 5, 6, n number of angles. As long as you are on the same segment and you're standing on the same chord, it's equal. Then I came down to a specific case where I said, ये समझाया था अस्मिता को. Okay. Next, if you are a equal arc, then you are making a diameter. Your chord is a diameter. Then the angle will always be angle in a semicircle is a right angle. Third one is this. Actually, one more portion is still remaining. That is the tangent portion. If you want, I can continue, but it depends upon whether you have strength. Strong. Chale. Aye. So arc and angles are over. The next part is to know about tangent. Just drop a small message, specifically Sastra and Srinika. Put a message to your home that you will be taking some time to come. And tangent. So let's first understand what is a tangent. Tangent में एक ही formula है. It's simple. Kirtan, should I drop a line to your mom? If you want, I can put it. No, it's better I put it. I'll just put it. I'll put it on the parent group. Okay. So let's go with tangent. Tangent is a line that touches a circle at one point only. A tangent is a line that touches a circle at one point only. That's why we say, what discussion are you having? It's all going tangent. Means it just touched my head and went. It will touch only at one point. So how to draw a tangent? A tangent will look something like this. A tangent is a line which touches a circle only at one point. This is a tangent. Have you understood? And if you have a line which actually touches a circle at 2 points, this is known as a secant. Sec theta ka secant. This is known as a secant. Tan theta comes from tangent. A secant is a line which touches a circle at 2 points, whereas a tangent is a line which touches a circle at only 1 point. Understood? Right, very good. We'll not keep the secant one. Now, if you draw a line, now the point at which the tangent touches the circle, that particular point, this point P, this point P is known as my point of contact. Point of contact. Are we fine? Radius through point of contact will always be perpendicular to tangent. Radius through point of contact means if you are trying to draw a radius which is joining this then this will always be perpendicular, means this will be 90 degree, so as this will be 90 degree. Clear? Radius at the point of contact is always 90 degree. Okay. This is basic thing about tangent. The next basic thing, only I think one more or two more maximum. The next one is tangents drawn from an external point. Okay, we are trying to draw a tangent to this circle from an external point. So tangents drawn from an external point are always equal in length. Tangents, and you can have unique tangents only. Tangents drawn to a circle, whether this is in your course or not, this will help you, from an external point are equal in length. This is CBSE 9 and 10 combined now, are equal in length, which means, which says that this is my external point P and I'm trying to draw tangents to this circle. So one tangent would be, say, this. You can have only two unique tangents from this point. यहाँ से और अलग tangents हो ही नहीं सकते हैं. Given an external point, we can have only two unique tangents. Hey children, if it gets boring, then please let me know. I'll stop it. Don't worry. So, if this is, you try to draw two tangents from this point. चलो आपके लिए कोशिश करते हैं. Ashmita's request, we will draw. I'm starting from here, Ashmita. Where does the tangent go? You tell me.
Yes.
Huh? I think I can have only these two. Do you agree? Otherwise, cut jayega na. So tangents drawn from an external point are always equal. Now, how do we prove that equal? Although that proof is not required, but you can draw a line till here. Do you understand? And join the radiuses and use your RHS. What is RHS? R is equal to R. Agreed? Hypotenuse is common. Hypotenuse is common. Side is equal to side equal to radius. Two triangles are equal, so two lengths are equal. These two angles will also be equal. Tangents drawn from it. And last theorem, and then we are done. Last theorem. The last theorem says, this is also about tangent. Usually earlier we used to have these big classes, at least 1.5 hours and all. This used to be very common. Huh? Okay, the last theorem says that say suppose I have a tangent which is, sorry, I have a tangent which is, stay screen, okay. Right. Now, this is a mix of tangent and chord. So let me have a chord at the point of contact. Try to understand more than the theorem. You should understand. AB is a chord and B is the point of contact. Do you understand? AB is a chord and B is the point of contact. Now understand very clearly. Angle made by a tangent with a chord. Angle made by a tangent with a chord is always equal to the angle made by the chord in the alternate segment. Angle, this is called alternate segment theorem. The angle made by a chord with a tangent is equal to the angle made by the chord in the alternate segment. First of all, understand, this is my chord, this is my chord. Where was this angle found? On this segment.
Yeah.
So why did I teach you alternate segment? जिस तरफ आप ध्यान दे रहे हैं उसका opposite side alternate segment होता है. This is the alternate segment. And precisely if we go like this, angle made by a tangent with a chord is equal to the angle made by the chord on the alternate segment. Even this is true. Alpha plus theta is also a linear pair which is 180 degrees. So theta plus alpha is also 180 degree, which proves that cyclic quadrilateral opposite angles are 180 degree. Geometry is interesting. Do you get it? Isn't alpha and theta a linear pair? वही चीज है, अलग अलग जगह में घुस गया है अभी, छोटा सा नट बट इंजन के हाउसिंग में घुसा हुआ है. You need to look at with that perspective now. The angle made by a tangent with a chord is equal to the angle. So this chapter is all about knowing the theorems, knowing the findings.